All right. Let's crack on. This was easy. This one we know first of all is being rubbed off. So if it's being rubbed off by default, it's going to be friction. And second one, the rods. Okay, so we need to be careful with this one. So we've got the rod here, and the rod becomes negatively charged. Now, if it's becoming negatively charged, why is it? So it means they are gaining something. Okay, so what are they gaining to become electric charge? So they are gaining electrons. So the only possible is this one. Okay, now one thing I would say is protons do not move. Okay, now you guys on chemistry, we've also done this in radioactivity. Protons, they are inside the nucleus. So they are inside the nucleus. Okay, if you're hearing me, they are inside the nucleus. Okay, so the nucleus, pretty much, you have the strong nuclear force there. Okay, it's pretty much strongly being held together. But the electrons, they are in orbit, while they are around in shells. So it's much easier to knock off the electron than to go deeper and take the proton out. Okay, so if you remember when we did this practical, as a class practical earlier, when you were using the rod, the ruler, so all you were doing is you were pretty much moving the electrons. Again, make sure it's only one mark. Now this one, we need to circle the anomalous one from the results. Now all we can see in the anomalous data is the one that's the odd one out pretty much. The odd one out I can see is this one. All we have to do is circle it. That's it, done. Now what should we do with this? We just need to ignore it. So we ignore it. We just ignore it. Okay, so therefore when we are going to be calculating our mean, now what does the mean means is an average. So if we're going to calculate our mean, we are going to ignore it from our mean. So therefore we have minus 61 plus minus 50. Okay, and then what do we do? And then we divide it by 2, and this will give me our answer 60 minus 60. So the mean is going to be minus 60 there. Okay, now we'll get 2 marks if we ignore it, because we said to ignore it, to exclude it. So we need to show that we are doing that. Okay, now this one, for this one, the year 11, so the year 11 they did a mock, and this was on their paper 1, so paper 1 mock. So what I'll do is I'll put it in the description below, so you can watch this from 25, 27. Okay, so 3 marks again, because I went through the questions already, so it's already, the video's already ready, it's already there, so make sure that you do watch those points. Again, 3 points for 3 things. So this, right, so the year 11 they did this pretty much this they did this in December, so last December gone. Okay, so now what we have here, we have energy stored increases when the rubber is being stretched. So what energy is that? So this is the elastic potential energy. Now, what is the main method the energy get transferred in this case? Method, process. So therefore, now we are using a force to stretch it, so therefore it's going to be mechanical. Okay, mechanical or mechanically. Now, what is the source? Where is the energy coming from? I can see the energy coming from the guy's hand, the hand slash fingers. Okay, this is the source. Okay, now state how the graph shows that the rubber band does not obey Hooke's law. Now, first of all, we can see that. First of all, we want to know what Hooke's law. If you remember, we need to go back to the first question. Hooke's law states that it is directly proportional. This is not directly proportional because it is not a straight line. Okay. First of all, we're going to say that this curve, so this graph, is curved. Okay, it's not a straight line. And look, it's 1 mark. I don't need to talk of anything more. Okay, I don't need to talk anything more. Now, explain how the graph shows it is elastic. Now, first of all, we're going to define elastic. So elastic means, so by explaining it, it's going to tell us what's going to happen. Okay, by explaining. So it means that, okay, so for it to be elastic, okay, it has to return to its original length. Okay, after the force has been removed. Okay, so we have 2 marks. So it needs to return to original shape. Sorry, its original length after it has been removed. After the force has been removed. Okay. Now, if you look carefully, we can see that the line returns to 0, to, let's say, the origin. Okay. So if I go back to the graph, so look at the arrow. So we start here, we went up, and then we came back. So when the unloading means the force is removing, yeah. So it's just English. So and then we went back to where we started. Even though it does not obey Hooke's law, yeah, it's not directly proportional, blah blah blah, and yet it is elastic because the fact that it's going back to its original shape, sorry, original length. Okay, that is the thing. It's always about the length in this case, the original length. Okay. Now, stretches, then released, it moves up vertically. Okay, so pretty much the rubber band goes up. Okay, and then it hit a certain height. Okay. Okay, so it goes from one to next. So now, first of all, we know that at the start it's gonna have kinetic energy because it's moving up, and at the end it's gaining gravitational potential energy. So therefore, we can say that kinetic energy is equal to gravitational potential energy. Fair enough. So half mv squared is equal to mgh. Okay, is this correct? Yes, of course it's correct. Okay. So therefore, now the mass cancel out because it's the same rubber band that goes. So therefore, we're left with half v squared is equal to gh. Now we need to work out the height. So therefore, this is just quick math. So therefore, half is there. So the g goes down, and we're left with h. So therefore, v, we know v is 13 squared divided by 2. Now gravity we know is 10 or negative 10. I'll just take 10 in this case. Okay, and this will give me h, and then h will be 8.45. Now the question also asks me to do in significant figures. Now I trust that you've done significant figures in maths already, so therefore this becomes 8.5. Okay, again, so make sure that we understand what's going on. Okay, so whenever we are reading a question, you need to put in your head what's going on. If you can't see it in your head, write it down, draw it. So look, it starts from somewhere, it's going up. Okay, so what do I know if it's going up? Okay, got this energy, got this energy. Okay, now I know this happened. I know the equation. Now, do I have the numbers that goes into the equation? Yes, I do have the numbers. So therefore, what I've written down makes sense. Okay, what I've written down makes sense. Okay, now let's go down. Now here what we've done. So the band has reached, and now we have reached the maximum height. So now we've reached the maximum height. So height. Explain the motion. Okay. as it falls from the height to the ground. So now it goes from the height to the ground, so it's going down. And refer with forces, 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 forces. How many times do I repeat forces? Forces, nothing to energy. So therefore we're going to ignore energy. Okay, let's start from the top. So when the band is at the top, here, number one, or number one here, so the only force acts on it, so only weight acts on it. Okay, so since the only weight is acting on it, it means number two is going to accelerate down. Okay, now, so weight is pointing down, so therefore it's going to accelerate down. Now, why does it accelerate down? Because since there's only weight on it, so therefore the resultant force is down. Okay, so this is okay. So actually, let me just fix this up. So this is still number one. Okay, now it says here, then number two. Oops, number two. Let me just number two. Okay, number two. What happened? It accelerates downwards. Okay, so the air resistance or the air drag increases. Okay, so as it falls, the air drag increases. Okay, now as the air drag is increasing, what does this mean? This means that the resultant force, because earlier at number one, the resultant force was down, okay, and it would just wait. But now the resultant force has changed because we have the weight, we have the air drag that's countering it. Therefore, the resultant force decreases. Okay, now for example, if I just put some numbers, if the weight of the rubber band, I don't know, let's say is 10 Newton, now the weight stays 10 Newton, but now the air resistance is increasing, so therefore now, let's say the air resistance is 2 Newton. Therefore, the resultant force, here the resultant force will be 10 Newton, because there's only weight. Here, the resultant force would be what? 10 equal 2 will be 8 Newton, so therefore it has decreased. Okay, has decreased. Now, if the air resistance, so if the resultant force has decreased, then the acceleration decreases. Okay, does this make sense? Okay, does it make sense? Fair enough. And this should be enough to get our full marks. Now, why is this enough? Because the question say does not reach terminal velocity. So we're going to stop there because third point, this is one's going to reach terminal velocity. We don't care about that. So we mentioned the weight acts on it. Fair enough. We mentioned it accelerates down. The resultant force, air drag increases, air resistance increases, resultant force decreases, acceleration there. You got class. Let's move to the next one. Okay, now this one is another question, moment question. Let's get this done properly. So moment is force multiplied by distance, which is perpendicular. The force is 28. The distance is 15. What is this number? Centimeters, so therefore it's going to be 0.15. Okay. And therefore we could get 4.2. So 4.2. Now the unit is very easy. Okay. Now, if you want to know the trick of the unit, you always ask yourself, what are you doing? So I have the force. I'm multiplying it by the distance. So what is the unit for force is what? Newton. I'm multiplying it by the distance, which is meters. Here you go. Okay, how easy is this? Now, moments. To increase the moment, what do I need to do? I need to look. I'm using force, so therefore I increase the force. So therefore, larger force applied. Okay. I increase the force. Fair enough. Second one, what do I do? Okay, I can use a much longer wrench. So, okay, so I can pretty much, okay, increase perpendicular distance from the nut, which is the pivot. Okay, so pretty much in other words, simple word, I'm using a longer because there's more lever. Lever increases, but we want to make sure. Okay, so here we go. Now another question, nicely done. Okay, so we're looking for the distance travel. First of all, we know it is distance travel when the force applied. It is a circumference. This is a quarter. Now the question tells us is a quarter in this case. What do we need to do? First of all, circumference of the circle is 2 pi radius. What's the radius? Is 15 centimeters. Okay, now look at that. Look at this. The answer want it to be in centimeters. So I don't need to convert. So here, no convert. Therefore, I'll leave it in 15 centimeters. Okay. So therefore, I'll end up with 30 pi, which I need to convert, which I need this in decimal, yeah? Okay, I need this decimal, so therefore, okay. Now, this is a quarter, so therefore I need to multiply this by 1/4 to give me the answer. So, 3.6. There we go. Now I have work done. Now, work done is energy. Look, energy. So it is the force multiplied by the distance. The force, where's the force? Look, the force is there. 28. So the force is 28. The distance. Now, since I'm looking for energy, so now I need to convert. So this need to I need to convert now. Convert centimeter to meters. So therefore, it's going to be 0.20. Okay. And this will be 6.6. So the answer is 6.6. Again, so make sure that whenever we are performing our work, we are paying attention to what we're doing. Yeah. So at the end of the day, you want to prove yourself. Yeah. You don't just want to do the work for the work's sake. You want to do it. You want to do the work for your sake. Yeah. Not for the work's sake. Because the work, if you're doing it for the work's sake, then the work gains nothing. But you need to do it for your sake because you are the one who's gonna have to gain stuff from it. Yeah. Okay. Again, make sure everything is sorted out. Make sure make sure that you wake up now. Okay, before it's too late. Okay, so make sure that you wake up now. So year 10, make sure that you wake up now. The stuff you don't know, let's do something about it. Okay, let's find out. Let's watch videos. Let's practice. Okay, so practice question. You know what you don't. You know what you don't know. You done the questions. You did the 17th. You did your end of years. You know what you don't know. Let's fix this. How can we fix this? Okay, I made this video. You can watch the video. There's loads of videos. Again, check, learn, check, learn, check, learn, check, learn. Yeah. Otherwise, if it gets to next year, it's going to be gone soon. Yeah. Okay. So I've spoken to year 11 who pretty much they've now started their real GCSE. You know, the exam has already started. You know this. You know this already. Yeah. So some of them are already having panic attack. Okay, because they are leaving everything to the last minute. I'm telling you, last year, I'm telling you this year, you have time. Make sure you sort this out because it is for yourself. Okay, fix yourself today so that in the future you already been fixed.